Hey guys, this is Madhav Kumar. Today I am going to teach you about rational number. If I want to ask you, what do you mean by rational number? I hope you will say that the number which can be written as in the form of p by q, where q will not be equal to 0, that number can be said as rational number, obviously. But if I ask you why q will not equal to 0, then you can say that it will be not defined. If I want to ask you that why it will be not defined, and later if I will ask you why rational number can be written as in the form of p by q, then obviously you will lag here. Today I will deeply teach about rational number. Why we can write it as in the form of p by q. Actually, decimal presentation of rational number, decimal presentation of rational number will be first one, terminating. Terminating, it means value stops after some decimal points, and second one will be must. If the decimal presentation of that number is not terminating, then it will be must recurring. If not terminating, then number must should be recurring and repeating and regularly repeating, not it will be continuously repeating. Just look here as example: 2.4, 3.5, 1.021, 1.31 and 2.321. If you see consciously here, then you will see that 2.4 value stops after one decimal point, 3.5 value stops here after one decimal point, value stops here after 3 digits, and value stops here after 2 digits, value stops here 2.321 after 3 digits. Can we write it as in the form of p by q? Just look here, 2.4 can be written as, if we want to remove decimal point, then we can write it as 2.4 upon 10. Yes or no? It means 24 upon 10. 3.5 can be written as 3.5 upon 10. If you want to remove decimal point, it means 35 upon 10, and so on. 1.025 can be written as 1.025 upon 1 upon 102030. After decimal point, 3 digit here, so we can put 30 in the denominator. So on. 1.31 can be written as 1.31 upon 100. If we want to remove decimal point, it can be written as 131 upon 00. 2.321 can be written as in the form of 2.321 upon 1000. If we want to remove decimal point, then we will divide 1 upon, after decimal point 3 digit here, then we will put 3.30 in the denominator. Yes or no? Yes. Here 2.4 value stops here, it means value terminates here, value terminates here after some decimal point. It means value stops after some digit. Yes or no? 1 digit, 2 digit, 3 digit, 5 digit, so on. Here, if you look consciously here, then 24 upon 10, here 24 it is integer, 10 also integer, 35 here also integer, 10 integer, here denominator, nominator, both are integer, and q equal to not 0. Denominator can't be 0 in a fraction. Why? You can say that it will be not defined. Yes, it will be not defined. Yes. Why it will be not defined? If I want to ask you why will be not defined, if you write it as p upon 0, it means p upon 0 means p divides in 0 parts. Yes or no? Just look here, 1 upon 2, it means 1 divides in 2 parts, it means we will get 0.5. 1 upon 4, it means 1 divides in 4 parts, or we can say that 1 in 4 parts. Yes or no? 1 upon 5, it means 1 divides in 4 parts, it means we can say that 1 in 4 parts. Yes or no? 1 in 5 parts. And just look here, 3.4, it means 3 in 4 parts. Yes or no? Yes. Then we can say that p upon 0, it means p in 0 parts. P in 0 parts. Just look here, whenever we will take p, q, r as anything, then we will take as example number, because a number is a language of mathematics. Yes or no? Yes. Then if p equal to 1, then it 1 upon 0, it means, is there any 0 in 1? No 0. Yes or no? 2 upon 0, it means there is any 0 in 2? No 0. There is 3.0, it means there is any 0 into 3? No 0. It means it will give you 0 to 1, 2, 3, 4, 5, 6 up to infinity value. Up to infinity value, 0 to infinity value. And even can say that 1 upon 0, it means there is 1 0. Someone says that there is 2 0 in 1, there is 4 0 in 1. Some way say that then infinite 0, because if you multiply 0 into 0, then it will be, you will get 0, 0 into 1, 0, 0 into 2, 0, 0 into 5, 0, 0 into infinity, 0. Yes or no? So q will be not 0. Q must be not 0. Q must not be 0. Okay. And if decimal presentation of number is terminating, then it can be written as in the form of p by q, just like here. And look here, if the decimal presentation of that number is non-terminating, it means value doesn't stops after digits and it goes to infinity. Just look here, 2.4 to the recurring, or we can say that, write it as 2.4 to the point, it means recurring. It means 4 repeats regularly, 2.4444, and 4 it goes to infinity times, so on. 0.3 to the recurring, it means 3 repeating here regularly. Just say as example, 1.24 to the recurring, 4 to the only 4 to the recurring, it means 1, 2 and 4 comes regularly, 4 comes regularly, and it goes to infinity times, 1.244444 and goes to infinity. And 3.546 and 46 to the recurring, it means 3.54646464646 comes regularly and regularly up to infinity times. Can we write as 2.4 to the recurring in the form of p by q? Yes or no? You know that this is a short form to write. If number is non-terminating but recurring, we can write it as 2424 minus the number which is not repeating here, total number, 2 upon 9. It means 22 upon 9. If we want to cross check here, then just divide it. Just divide it. 9 to the 18 and it gives you 4. After that he will put his decimal here and it will be 14. 9 4 ja 36 and it gives you 4. Instead of decimal we will put 0 here and 9 4 ja 36, 4. Here 4 comes regularly. After that, instead of decimal you can put 0 here and 9 4 ja 36. It means it will be give you 4. 4 comes regularly here. Always reminder here, 4 reminder here. Yes or no? Yes. You can check, cross check here. It means 4 comes regularly and repeating regularly up to infinity. Then we can write it as 2.4 to the recurring. Yes or no? And 0.3, it means 3. 0 3, it means if 0 is before the any number, then no any change in that number. 0 3 minus 0, it means 3 upon, instead of recurring number we can put 9 in denominator, 3 upon 9. It means 1 upon 3. Yes or no? If you want to cross check here, just cross check here. Just divide here, 0 point. Then instead of decimal point we can put 0 here. 3 3s are 9 and you will get 1. Instead of point we can put here 0. 3 3s are 9, 1 here. Instead of point we can put here 0. 3 3s are 9, we will get 1. It will be goes to infinity. This value doesn't stops. This value doesn't stops, but 1 is regularly repeating here. 1 is regularly repeating here. It must be regular. It means there is no any number which breaks its regularity. If there will be any number 1 after 2 here, and just look here, 4 4 is just coming here, and 5 is just come here randomly. Then 5 will be breaks it, 5 will be break its regularity, yes or no? Then it will be repeating, yes, but not regular repeating. We can say that it regular but not regular repeating. It decimal presentation must be, if not terminating, then it should be regularly repeating regularly. Then we can write it as 0.3 to the recurring in the form of p by q, 2.4 to the recurring in the form of p by q, where denominator is not equal to 0 because of there is any no parts in natural number. 0 will be not present in any natural number. And we can write 1.24 to the recurring, 124 minus 12. Instead of recurring, we will write 9 in denominator, and after there is a single digit which is not recurring, instead of which number is not recurring, we can 0 put here, and 124 minus 12 we can write it as 1 and 2, 112 upon 19. Yes or no? And if we want to make it co-prime, it means there is no common factor in denominator and numerator, then we will divide with common factor. 3 3s are 13, and 3 3s are 9, 3 3s are 9, and it will be not divided by 3, it will be divided by 2, 2 5 are 10, 2 56 upon 45. There is no common factor in denominator and numerator, it means that it is co-prime. It can be written as 1.24, 4 to the recurring can be written as 54 upon 45, where q equal to not 0. This number is recurring. If we want to cross check here, then we can cross check over here. We will get 1 over here, 11 over here. Then we will put decimal point over here, and instead of decimal point we can write 0 over here. 45 3s are, it will be more than 110. Then we will put 2 over here, 45 2s are 90, and we will get 20 over here. Instead of point we will put 0 over here, and 45 4s are 180. You will get 20 over here. Instead of point we will put 0 over here. Here 200 comes here, 200 comes in remainder here. Then 20 you will get 20 regularly in remainder, and you will divide 45, and in quotient we will put 4 here. It will be goes to infinity. Value doesn't stops after the decimal point, and it will be goes to infinity. Whenever we can write it as in the form of p by q. So decimal presentation of rational number will be terminating. If a number is not terminating, then it must be repeating or recurring and regular recurring here. So we can write it as in the form of p by q form. P by q, it means fraction form, where p and q should be integer. Integer can be denoted as capital I, and its range is minus infinity to plus infinity, and q denominator must be not equal to 0, not defined. Yes. Then the number can be said as rational number. That number can be said as rational number, and rational number is denoted as capital Q. This is a collection of rational number. The collection of rational number has 3 types. First one is integer, which is complete number. Second one is a fraction, and third one is decimal. number. And in this collection, in the collection of integer, there is a collection of whole number, and in the collection of whole number there is a collection of natural number. First one, natural number. The word natural is closely related to nature, yes or no? It is closely related to nature. Natural means which is related to nature. It means the number which is invented initially. After that we will add some zero and some negative value and then fraction form, then decimal form. Initially invented, the number which is initially invented. Nature means which is closely related to nature. It is just a number of counting, the counting number, and it can be denoted as capital N, and its range is 1, 2, 3, 4, 5 up to infinity. And second one is whole number. The word whole, it means complete. After adding zero, the collection of number is complete. The word whole means complete. After adding zero, the number will be complete, just like as adding zero in natural number. Adding zero in natural number, it makes the collection of natural number complete. Makes the collection of number complete. So we can say that this is whole number. Whole number can be denoted as capital W, and its range is 0, 1, 2, 3, 4, 5 up to plus infinity. And third one is integer. Integer is natural number of negative value of natural number and positive value of natural number adding with 0 is called integer. Positive value of natural number can be denoted as n, 1, 2, 3, 4 up to plus infinity. The positive value of natural number, it means just it is a set of natural number. And second one is negative value of natural number. It means just put negative sign here, infinity up to -1, -3, -2, -1 and 0. Negative value of, just negative value of integer. And third one is adding with 0, or we can say that whole number and negative value of natural number is called integer. Integer can be shown as capital I or Z, and its range is -infinity to plus infinity, and we can write it as 0, 1 plus -1 plus -2 plus -3 and plus -4. It will be goes to plus minus infinity. This is a collection of integer. This is a container of integer. And fourth one is fraction. You have already know about it. Fraction, it means the number can be written as denominator upon numerator upon denominator, numerator upon denominator format, and denominator should not be equal to 0, and numerator and denominator may be integer. This is a fraction form. And fifth one is decimal. If we will divide numerator by denominator and want to get the decimal number, then fraction will be in the form of decimal. We will use 0 point, it means decimal point of fourth decimal number. Its base is 10, just 10, base 10. And this whole collection of this number will make the set of rational number. Okay. And after that, there is some operation in mathematics to make your problem easy. Just look here. If you want to multiply 104 into 96, it is 104. It can be written as 104 into 100 minus 4. Yes or no? It will be quite easy to multiply this type of method, and we can write it as a plus b into a minus b, this format, and it can be written as a square into b square. A square minus b square, a square will be 100 to the square and 4 to the square, and 140 over here, and 4 4 are 16. We just subtract 10,000 minus 16, then it will be 4 8 and then 9984. We will get it. Is quite easy to write here. So there is some mathematically operation to make your problem easy. There is some property here. There is 4 operation in mathematics. You are already known about it. There is operation in mathematics, 4 operation over here, which is adding, subtracting, multiplication, and 4th one is division. Yes or no? This one fourth operation in mathematics, in maths. And some properties to make your problem easy. First property is closure property. First property is closure property. Closure, this word is closely related to clause. Closure, it means which clauses anything can be said as clause. It will give you single result. Single result. It will give you only single result. And it just clause. It means operation just complete after equal to sign. Clause and operation which is adding, subtracting, multiplication, or division, just clause after equal to sign. Clause after, just after clause equal to sign. Just look here as example. 2 plus 1, you will get 3 here over here. 3 into 4, you will get 12 over here. 4 minus 3, you will get 1 over here, and 4 divided by 2 will get 2 over here. Here result is single, 3, 12, 1 and 2, and operation is just closed after equal to sign. Just closed. Operation is just closed after equal to sign. So we can say that this is a closure property in mathematics, which have 4 operation: adding, subtracting, multiplication, or division. After that, we will see that the natural number, whole number, integer, and rational number follows this property or not. First one is natural number. Natural number in under closure property, if I want to add 2 natural number, first operation is addition. Just look some example over here. If you add just 2 natural number, 1 and 2, you will get 3, 5 and 6, you will get 11, and so on. You will get 15 over here. Here in operator and operation, in operating side, both number is natural, and you will also get natural result, natural number result. If operation in addition of natural number, then you will get only natural number in result. So it can follow the closure property. Natural number follows the closure property under addition operation. Second one is subtraction. Just divide 2 natural number. 2 upon 1, you will get 1 over here. If 1 minus 2, then you will get minus over here. Here both number are natural. In operator, minus in mathematics, we can say that this type of operation, 4 operation over here, and plus, minus, subtraction, addition, multiplication, it as operator. Because of it operates of number, and number can be said as operand. Yes or no? Here under subtraction, if we subtract 2 natural number, then you will not get always natural number. You will not get always natural number, so it doesn't follow subtraction under closure property. And third one is multiplication. If you just multiply 2 natural number, then you will always get natural number result. So it's follow under closure property. Natural number follows its multiplication. You will get always natural. If you multiply natural number in natural number, then you will get only natural number. Fourth one is division. Just divide two natural number. 4 divided by 2, you will get 2 over here. But if you divide 1 divided by 2, 2 divided by 3, then 1 divided by 2, you will get 1 by 2. It means 0.5. And 2 upon 3, you will get 2 upon 3. And this will be recurring number. You will get 0.6 to the recurring. Here, if you divide two natural number, then it is not necessary that you will get only natural number. So it doesn't follow closure property under division. This one is following over here. Subtraction doesn't follow, multiplication follow, and division doesn't follow. Second number is whole number. Whole means complete. After adding 0 in natural number, it is complete. Natural number makes complete. Whole number under closure property in addition operation. Just look here. If you just add two whole number, just like 0 plus 1, you will get 1. 0 plus 3, you will get 3. And 1 plus 3, you will get 4. If you just add two whole number, then you will get only whole number. It means it follow the closure property under addition operation. Second one is subtraction. Just subtract two whole number, just like 1 minus 0, you will get 1. But if you subtract 1 minus 2, then you will get minus 1. Minus 1 is not a whole number, 1 is a whole number. So it is not necessary. If you subtract two whole number, then you will get only whole number. So it doesn't follow. Minus 1 is integer, doesn't follow. So whole number doesn't follow closure property under subtraction operation. Third one is multiplication. If you just multiply two whole number, 1 up into 2, then you will get 2. 2 into 4, then you will get 4. 0 into 6, you will get 0. Here, if you just multiply two whole number, then you will get only whole number. It means it follow closure property under multiplication operation. And fourth operation of natural whole number will be subtraction. Is division. Fourth is division. Addition, subtraction, multiplication, and division. If you just divide two whole number, then will you get only whole number and other number? Just divide 1 divided by 5, you will get 1 upon 5. This is a fraction form. It means 0.2. 5 divided by 2, you will get 5 upon 2. It means 2 upon 5. If you divide 4 divided upon 2, then you will get 2. If you divide 6 divided by 0, then you will get infinity. So it is not necessary that if you divide two whole number, then the result under closure property will be always whole number. So we can say that whole number doesn't follow closure property under division. And third number is integer. The range of integer is minus infinity to plus infinity. Integer under addition operation. If you just add two integers, just like 0 plus 1, you will get 1. Minus 1 plus 2, you will get 1. And 4 plus 0, you will get 4. In addition operation, if you just add two integer, then it will be always a integer number. So we can say that result is always integer. So we can say that it's follow closure property under addition. And second one is subtraction operation. Just look here. If you just subtract two integer, just minus 1 minus 2, then you will get minus 3. Minus 5 plus 2, then you will get minus 3. And 2 minus 0, you will get 2 over here. It means If you subtract two integer, then you will get only integer. It means it follow closure property under subtraction operation. Third one is multiplication. Just multiply two integer. 0 into 1, you will get 0. 0 into minus 1, you will get 0. 4 into minus 5, you will get minus 20. Minus 5 upon 2, you will get minus 10. It means if you just multiply two integer number, then it will be always integer. It will be give always integer number in result. So we can say that it follow closure property under multiplication operation. Fourth one is division. If you just divide 1 upon 2, then you will get 1 upon 2, which is not an integer. If you just divide 1 divided by 0, then you will get infinity. 2 divided upon 4, then you will get 1 upon 2. It means if you just divide two integer, then it is not necessary that you will only get integer number in result. So we can say that integer doesn't follow closure property under division operation. Yes sir, no?